In section 10.1, we'll briefly look at the English and metric system, mostly concentrating on the metric. And again, this is just a brief kind of overview of that section. When we're looking in the English system, length we refer to as a distance. And an inch would be pretty much our smallest measurement. We know that a foot is 12 inches. A yard is 3 feet, which then would be 36 inches, and a mile is 5,280 feet. When we look at volume, this is either for wet or dry. When we have a cup, that's 8 ounces. A pint is 16 ounces, which is 2 cups. A quart is 32 ounces, which is 2 pints, which then can be put into 4 cups. And a gallon is 128 ounces, which is 4 quarts. Now these measurements will be needed for the homework because you'll be doing some converting, which we refer to dimensional analysis. When we look at mass, mass is the amount of matter. So no matter where I'm at, the mass is always going to be the same, whether I'm on the moon or the earth. Now what you have to contrast that to is weight. And the weight is the force exerted due to gravity. And we know that gravity on the moon is less than on the earth. So you're going to weigh different, however your mass would be the same. Mass units, an ounce is just going to be the basic unit. A pound is going to be 16 ounces, and a ton is 2,000 pounds. Temperature. When we're in our English system, which, as you can see, they're all odd types of measurements, we are in our Fahrenheit system, or a Fahrenheit scale. Water freezes on the scale at 32 degrees Fahrenheit. Water boils at 212 degrees Fahrenheit, and your body temperature is approximately 98.6 degrees Fahrenheit. And you can see they're all kind of odd measurements. That's why there's been somewhat of a push at some point to go into metric, although we have not converted, but in some areas. And metrics is so much easier because all the units go together. They connect liquid to dry, where in the English system we do not. The metric system is based on powers of 10. And so we're going to be looking a little bit at the metric and why it might be wise to know the metric system in terms of length, volume, and mass, and how they're all related. And again, we'll be doing that kind of as a little exploration in class. So if we do our standard unit is going to be, we'll place it in the middle here. Our standard unit is 1. And as we go down, we have deci, which is 1/10. We have centi, like in centimeter, which is 1/100th. And we have milli, which is 1/1000th. So if you recall, that's kind of a 10 to the negative 1, 10 to the negative 2 type situation that we looked at earlier. 10 to the 0, 10 to the negative 1, and so forth. So that was our negative powers that we had talked about back in Math 115. Standard unit going up, not deci, but this is going to be deca. Like decade, that would be 10. Hecto is 100, and kilo is 1,000. So those are the prefixes that go on to the measurements for length, volume, and mass. So if we're talking about length, we are in meters. So we have the kilometer. Our standard unit is the meter. And obviously we measure a lot in centimeters and in millimeters. These obviously have abbreviations. Kilometer, meter, centimeter. In volume, we have the liter is our base. So kiloliter, liter, and oftentimes we use the milliliter. So we're just kind of showing you some of the basic ones that we have. Mass is then going to be, as a base unit, it's going to be a gram. And lots of times we look at a milligram, and we might look at a kilogram. So that would be our mass unit. Our temperature has a different type of measurement. It is Celsius. And what's unique about this, instead of remembering these numbers up here, the 32, the 212, which are kind of odd measurements, water freezes at 0 degrees. Water boils at 100 degrees, and this is all in Celsius. And your body temperature in relation to that would be 37 degrees. But it makes sense to make freezing and boiling powers of 10. So again, we'll be discovering kind of the connection between all of these in a little exploration in class.